Aus der virtuellen Welt gehen wir jetzt weiter in die modellbasierte Welt. Björnemark aus Schweden wird uns jetzt vorstellen, wie die Qualitätssicherung der ADAS-Anwendungen mit einem modellbasierten Ansatz passiert. Åsa arbeitet bei Vector Schweden seit 2003, also auch schon eine ganze Weile, ist dort als Produktmanagerin für die Testtools zuständig und leitet die entsprechende Abteilung dort auch. Du hast einen Masterabschluss aus einer ganz anderen Ecke der Welt, nämlich aus Sydney. Ja, aber jetzt kommen wir hier wieder mal auf den Boden der Tatsachen und zurück zur modellbasierten Welt. Also, bitte sehr, deine Bühne.
Vielen Dank. 2 years ago, Dr. Matthijs Klomp met a colleague of mine in the corridors of Volvo cars, and they started talking about connecting different modeling tools. CANoe connected with other modeling tools like CarMaker, for example, or Adam's car. Dr. Klomp is a vehicle dynamics expert at Volvo cars, so he's very used to working with a lot of simulation tools. And he also knows CANoe very well. So his idea started some projects that we did together with Volvo Car, and one of them I will describe more in detail here in this presentation. The other one is added as an attachment at the end, because I think I do not have time for that. So before we go into the projects, let me show you a statement that I got in an email from Volvo Car from a test engineer working together with Dr. Klomp. We are building fewer and fewer test vehicles, and we need to find alternative ways to verify functions in early phases. We see CANoe, CarMaker, and VT Studio as very good solution to meet these requirements. So, if OEMs are producing less and less test vehicles, how can we go about ensuring the quality? Can we still log everything and then use a simple replay to the real ECU to debug defects? I fear that that will be a little bit difficult, especially with some IP communication, as my colleague talked about just before. So what about an alternative approach? Everybody in Scandinavia is talking about continuous integration these days. And Dr. Klomp thinks that continuous integration demands tools. It cannot be done with manual testing in real vehicles, at least not only that. We also think that we need a lot of reproducible test runs, because we want to find defects early, and then when we get a fix, we want to replay the exact same test run or test scenario to check that the defect is gone. We also need a high number of scenarios, and those of you who saw Dr. Sachs' presentation earlier can easily think about all these scenarios that we have not been able to test early on before. And last but not least, we also need traceability. Probably it will not be enough to just say that we have tested our functions. We probably need to be able to prove that we have done this, and also to reproduce the exact same test scenario again. So, having said that, let me start talking about one of the projects that we did together with Volvo Cars. It's called Active Lights. And the function itself is developed by a Simulink model at Volvo Cars. So it's not developed by a supplier. And it's tested very early on, pure virtually, with Simulink in co-simulation with a tool called CarMaker, which you can see at the very right there. CarMaker is a tool for simulating roads vehicle dynamics, cars, driver behavior, and such. So certain aspects of the function can be verified purely virtually, but we cannot get the timing behavior, the real-time effects, or see how the function will work with real hardware. As one step closer to reality, Volvo wanted to also include real hardware, which you can see here on the picture below. Let's see if I can... How do I point with this one? Or never mind. Here you can see the video. CarMaker is now simulating that the vehicle is moving. And CarMaker is sending some signals to CANoe. CANoe is handling the ResBus simulation for CAN, Lean, and FlexRay for the real ECU. So CANoe is connected to the real ECU. The real ECU is connected to the headlights, which you see in the video. And here we can verify how the function is working also with the real hardware, also with timing effects, real-time behavior, etc. This function, of course, is not a new function. It's already available in the cars. But the same principle goes for also the new functions that are developed now for coming models. So a small note about the rig components. We didn't see the GUI of CANoe, but CANoe was executing its real-time kernel on the VN8912, which you maybe saw on the video. It is connected to the real ECU, which in turn is connected to the real headlamps. And then we also had CarMaker co-simulating with CANoe, and the signal exchange is handled through an interface called FMI. So just a few words about what is FMI. It stands for Function Mockup Interface, and it's a standard interface for connecting different simulation tools. When you talk about FMI, you often also talk about FMUs. And an FMU is just a model which fulfills FMI. So it has some inputs, it has some outputs, it has a do-step function, and that's it. And you cannot really know how the model has been developed, if it's Simulink, Daimola, or whatever. And you don't have to know that. Advantages are that models can be reused throughout several tools, and you get a tool independence, which is very important to Volvo. How CANoe supports FMI? CANoe supports that an FMU, meaning a model that fulfills FMI, can be imported into CANoe. So CANoe does not need to know if this is a Simulink model or something else. It can just handle the inputs and outputs and execute it. CANoe can also export an FMU, and this is the technique that we're using when co-simulating with CarMaker. So we pick the signals that CANoe needs to exchange because they are going out on the real bus to the real ECU. We export the FMU and we bring this into CarMaker. On this website, you can check if you're curious that a tool that you're using, if it supports FMI, you can check it on this website, and CANoe, of course, is mentioned there as well. So, I was talking about continuous integration before, and I said that we need to test numerous scenarios. As Dr. Sachs said, if somebody is standing at a crossroad and there's an autonomous vehicle coming and the person is waving that the autonomous vehicle should proceed, what shall happen? Think about, we have a lot of scenarios to test. So Volvo Cars thinks that one powerful setup for this is to use CANoe as a test engine, which they already do, and to control the so-called test runs in CarMaker from CANoe. What is a test run? It is a certain road, a certain vehicle with certain vehicle dynamics, for example, Volvo XC90, together with driver behavior, maybe some traffic objects, oncoming traffic perhaps, maybe a moose in a curve, maybe night conditions. Because you see, for example, for active lights, we need to test in night conditions. And think about driving around in Sweden in summertime. That can be really hard to find darkness. So we need some other setup for this. What we want to do from CANoe during a test sequence is to load a certain test run in CarMaker. We want to start it, execute some test cases, then stop it, then start or load next test run, and let the tools do the work, maybe during night, during weekends, use the tools to the maximum. The test engineers most often don't want to work during nighttime. Here, reproducibility is also key, because as said, we want to be able to run exactly the same test scenario, because otherwise we cannot know that the defect we found before has really been fixed. So it could look something like this. We load some certain scenario, we execute the test, we load the next scenario, we execute the next test, and so on. And the signal exchange happens through FMI. That also makes it possible to change the tools here. If you use FMI, you can just connect another tool that supports FMI. One thing I haven't mentioned so far is the traceability issue. Volvo Cars is using Vita Studio, at least in these departments where this setup is used. So they can easily make sure that the test cases, the requirements that they have been covered by a test implementation. This can be done in Vita Studio in the traceability matrix. They can also filter out all the safety critical requirements and look at the ASIL levels and make sure that these have been covered with the test implementation to be later executed maybe during night. So the complete workflow for traceability could look like this. Volvo is not using Prevision, but they use a predecessor from Vector, and it's called Electra. Never the same, the principle is the same. We can export the traceability information. We import it into our test design environment and implement the test cases. We connect the requirements to those test cases. We build a test executable. The test executable can then be executed in our virtual or semi-virtual test environment. In this case, this is CANoe CarMaker. And the test report, which is generated, contains the traceability information, which can then be imported into the RQM system, where some metrics can be analyzed. How well do we stand in our test process? Also to that, Volvo, of course, wants to add continuous integration. Ooh, what happened there? Looks a bit strange. That's good when you're talking about quality assurance. So the tool motivation for these two tools, according to Volvo, for CANoe, of course, the instant network simulation for CAN-LIN and FlexRay, and soon also for Ethernet. The model generation wizard, there is a special Volvo variant created, which creates a CANoe configuration with a RESPA simulation for as many FlexRay and CAN networks as you would like. You just put the databases in a folder, and the generation wizard does the job, which really eases the work with creating network simulations. Another important aspect is the combination of using real and simulated ECUs. To switch between a simulated ECU and a real ECU in CANoe is really simple and fast forward. Test engine is important, and the automatic creation of test reports, of course, with the traceability information. And also the time-synchronized logging of all data, network data, GPS data, camera data, all that you need when you want to offline analyze your tests. CarMaker, on the other hand, and Dr. Klomp said once that he sees CANoe as the integration platform for functions and CarMaker as the integration platform for plant models, meaning the environment for the functions. So that's one way of looking at it. I'm not sure the IPG guys would say that it's the only way, but as simply explained. So as I've already mentioned, car, road, driver, maneuvers, traffic objects, light conditions, fog, rain, anything that has to do with the environment can be easily modeled by a tool like CarMaker. Of course, there are other tools like this as well. The reproducible test runs is really neat to be used. And of course, a very powerful visualization, as you saw in the video before. So I talked about FMI offering a tool-independent landscape. We have been testing the CANoe FMI support with Windows platforms. CarMaker Office, for example, is a Windows platform. With some Linux platforms, there is software called Concurrent used at Volvo cars in the driving simulator. It runs on a Linux 64-bit platform. We have CarMaker Heal, we have tested. That's a Linux 32-bit. And we have tested to import FMUs into CANoe made by different tools like Simulink, Daimola, etc. It all works very well. So the advantages, I think that's clear. I can run it through a little bit quickly. High number of scenarios, reproducibility, fix the bug, test again, of course. And for some cases, also a very accurate assessment can be done in virtual environments. Think about lane keeping systems, trying to judge whether we have passed the lane with 3 or 4 centimeters in a real car. Pretty difficult. Automatic traceability is possible with the tools, very important for safety, and continuous integration. I think this is one alternative for that kind of setup. So, will it replace human test drives completely? I don't think so. I think a lot of OEMs are driving around now, collecting information, collecting all these scenarios that we need to test, but it can definitely be a complement. And also to move the test to earlier stages. Short note about our experiences from these projects. We have done now for 2 years. We have used ordinary laptops, so no really expensive rig PCs with Mega Blaster 32 kernels or such. CarMaker Office is good enough in many cases. It jitters a little bit, but for CAN and FlexTrace systems, that's acceptable in some cases. If you need more hard real-time, you can use CarMaker Heal instead. Does not jitter at all, according to our measurements. We recommend a real-time platform for CANoe execution, of course, for these systems. And to be considered, and this is really important, the end-to-end timing requirements between the signal exchange. So if the ECU has some I/O, which is sampled with really high frequency, this needs to be considered, how to build up this setup. There are different alternatives, different variants. So I think there will be a variant that will work, but it's to be considered, definitely. Real-time platforms, of course, important as well. We have made different setups there too. But our conclusion is that Canon FlexRay networks have a natural delay, which makes this signal exchange work. So if we have a signal exchange on, let's say, 2 milliseconds, then we are oversampling, for example, a FlexRay network with a cycle time of 5 milliseconds. So according to our experiences, this works really well. And it has been tested for example, brake systems. So that's pretty time critical. Next steps at Volvo Car. I think I will skip some of these because I'm probably running out of time. But just to mention one big thing, Volvo is now preparing to add another function to this kind of setup. So for power steering, a rig is built up, just like this. So the project we did so far is the active lights that you saw in the video, and also for suspension module, active damping. There is a rig as well. And also some project work ongoing for using CANoe for RESPA simulation in the driving simulator at Volvo. And as a conclusion, I think they have found a really good alternative for continuous integration with either a pure virtual or a semi-virtual environment. So what's next? That's actually to increase the test coverage, to add more test cases, add more functions, more rigs, and just keep going. And there, of course, we have a lot of ideas as well, but that's a completely different presentation. Thank you.
Okay, herzlichen Dank. Ich bin beruhigt, dass das Licht auch im betrunkenen Zustand funktioniert. Ja, Ihre Fragen dazu? Die FMU-Integration, die du uns gezeigt hast, ist ja sehr, ja, sieht ja sehr mächtig aus. Wie aufwendig ist denn das für den Anwender?
Actually, it's very easy to use. So I'm not an FMI expert, and I don't need to be one, because I can just use it without knowing the details of the standard. In CANoe, there are GUI elements to pick out the signals that you want to use for signal exchange. Press a button called export, or press a button called import, choose the FMU that you got from somebody, and then you start using it. When you import an FMU into CANoe, you get the system variables just as you would with a Simulink model. So, and in CarMaker, of course, it's about the same handling. So it's not at all, that's not time consuming. What's time consuming here is to create the simulation models, the plant models.
Mhm.
Yeah.
Okay. Sie dürfen Ihre Fragen auch gerne in Deutsch stellen, so wie ich das gemacht habe. Ganz da hinten.
Ja, Thomas Drexler, Vektorinformatik. Mich hätte interessiert an dem Test-Setup, wer ist da jetzt eigentlich der Master? Einerseits hatte man gesehen, dass auf CarMaker-Seite Testszenarien definiert wurden, aber es wurde auch Teststudio verwendet, was ja bedeutet, dass CANoe-seitig Testabläufe definiert werden. Wie ist da das Zusammenspiel? Wer steuert da wen?
Actually, you can choose. There is a test manager in CarMaker. I don't know that functionality that well, but you can define some kind of tests also in CarMaker if you want to, and then just let CANoe do the RESPA simulation. But Volvo wants to use VT Studio because it gives you the advantages of traceability, variant handling, etc., and easy test generation. So in that case, it's CANoe that is the master. But the beauty of it is that you can choose, and you can do it differently for different setups or different ECUs, for example. It's all very clear.
Alles sehr einfach. Also, herzlichen Dank für den Vortrag und